My name is Jan. This is a wonderful and important stage. You're a wonderful and important audience, and I want to thank the organizers for inviting me here to bring us all together in a very important time in free and open source software. So I'm very honored to be here. Thanks for having me. I've been doing open source and free software and community work since the late 1990s. I started out in a community that taught each other and other people how to do websites in a project called Self-HTML that maybe one or other person knows about. But shortly after that, I joined the PHP project for a while, doing translation of the documentation, then doing the actual documentation, then contributing to the project itself, having a very normal progression to get into projects. And I've done a lot of stuff since, but the main stuff that I do these days is working on Apache CouchDB and Apache PouchDB, which are really nice databases for building offline-capable applications, which is not what I'm talking about today, but if you want to talk to me about that, find me after. I do this mainly in the context of a company I helped found called Neighbourhoodie. That's my day job with a bunch of lovely people. We do support for Couch and Pouch. We do build offline-capable apps for others. We're a general-purpose development shop as well. And this is why it gets interesting and why I'm here. We are an implementation partner for the Sovereign Tech Agency. And today's talk is about the work that we've done in the past. It's a little bit of a softer talk, just before lunch. You can zonk out a little bit. There's going to be a bunch of fun anecdotes and some lessons learned from what we've done for people who want to do this in the future. And maybe they can learn something from, or you can learn something from the work that we did and make sure in the future it goes better as well. This is the team at Neighbourhoodie that worked on all these things. I helped very little with some of these projects, but these are the people who deserve all the credit for the work that has happened. Julia and Lehnardt are actually here in the audience, and if you want to ask them any questions, they're happy to talk to you as well. I'm just the pretty face. The Sovereign Tech Agency does not need an introduction here at this place, but briefly, maybe for people who are watching the talk later online, it's a German government-funded initiative to improve the free and open source software system, and does so in different funding programs, including direct funding for maintainers, one of the most useful things. Just give open source projects money, they know what to do with it. There's also a one-year stipend for individuals, some of them are here, who do something like, hypothetically, be the release manager for a mainline Python release. So they get to focus on the critical infrastructure for a year. There's standalone security audits done by another third party. And finally, the bug resilience program, which is not a term that rolls off the tongue or is an industry term that anybody would understand, oh, that's what they mean. And this talk tries to demystify this a little bit. But how did the big bug resilience program come to be? In the face of Heartbleed and Log4Shell, the German government wanted to take some money and say, hey, please give this to open source, or make sure this money is spent so open source projects are more secure in the future. And one of the most common ways to do this is a bug bounty program where people get paid if they find security issues in open source projects or in commercial projects, and then those get fixed, the people get paid. STA said, that's great. Talked to a bunch of open source projects, and they all said, no. What you're doing here is giving other people money to take away some of our time, because we have to evaluate each of these security issues that they report, and that takes a lot of time to do this thoroughly, especially if you incentivize them with money. You give them money to take away time from open source projects. And that makes no sense because we don't have time in the beginning, right? That's the main problem of any open source project. It's underfunded, nobody has enough time. So the STA said, okay, we'll turn this around. Instead of actively supporting people who find security issues, we help the projects themselves to be more resilient in the face of submissions of security issues so that they can fix it quickly, respond to it quickly, make a release quickly, so that we know the turnaround time from an open source or a security vulnerability being reported to a new release is as short as possible. Hence the term bug resilience. Through the last 2.5 years of work that we've done here in various projects, it turned out that there is an industry term for what we're doing here already. It is called reducing technical debt. And the new version of the STA, gets funded every 4 years. Then the next iteration starts next month. This program is actually called lowering technical debt. So we kind of had to have this little dance about how do we call this when we had a term all along, but that's how learning works. These are the projects that we've been working with. I'll run through them real quickly. Systemd, almost any Linux that runs anywhere runs systemd as the first thing it runs, and then systemd does everything else on your machine, and it provides a bunch of services to run an operating system. When we're talking about supporting fundamental software, foundational software, it's a system that doesn't get much lower than systemd. There's only the Linux kernel. It's very, very important here. PyPI, the Python package index, is how the Python community, and by extension, a big scientific community, is exchanging source code with each other. Again, it's an extremely fundamental project. Yocto, you may not have heard of Yocto, but you've definitely used a product that used Yocto to come into existence. It is a meta project that allows you to build a bespoke Linux distribution specifically for embedded systems. It's used in all sorts of things. For example, smart home devices. Say you want to make a fridge a smart fridge. You have a little computer in there. That little computer needs to run operating system. Yocto lets you make a bespoke operating system for just your needs with just the drivers you need and all the tooling that you need for that particular project. I guarantee you, you have used a thing that has been built with Yocto. It's so widely used, and it's not a common household name. At least it wasn't for me before we met the project. Genome also needs no introduction. It's a common desktop environment for Linux machines. There's a strong chance you're using Genome right now to take notes or whatever. Servo is the only independently funded web browser engine. It's extremely important for the openness and sustainability of the web and its future. It's one of the most important projects going on at the moment. I'm very proud to be able to contribute to that. Poplar is another one of those. You probably haven't heard of it, but it's a graphics library. If you're doing anything with PDFs on Unix machines or Linux, you are using Poplar. PHP runs a good chunk of the internet. Don't have to tell you how important this is. Log4j, every Java project that needs to put some logging into a file to explain about the state of the software itself is using Log4j. Reproducible builds is another meta project that isn't a project in itself, but helps to define standards and make other projects give them the opportunity to make sure that a binary that has been built from this open source project source code has actually been derived from a specific version of the software. The binary form is how any project runs on any machine. But if you make a binary, you can theoretically tamper with it and put some nefarious code in there that then does bad things on the target machines. But with reproducible builds, you can ensure that that hasn't happened. It's extremely important for supply chain security. Typo3 is a very established content management system. And Sequoia PGP and OpenPGP.js are PGP implementations in Rust and TypeScript and JavaScript. So again, very important for safe and secure communication. This is a wide variety of projects, but they all have in common that they are very fundamental to the field that they're in. And that's the kind of project that the STA tends to focus on. So what does bug resilience mean in practice? We have developed with the STA and with the initial projects, and thanks for the early projects for bearing with us while we develop this program on the fly, figure out what that actually means. It starts with analysis, as everything does. We look at the organization of an open source project. Who are the people in here? Is this a group? How geographically distributed are they? What are their communication patterns? What tools are they using? But also, do they have processes for reporting security vulnerabilities that adhere to common standards, that kind of stuff? Or is the contributor, is it a single person open source project, and how is their workflow and their funding situation and all that? And we look at a bunch of technical stuff, of course. The dependency is a huge vector for security issues. The fewer dependencies you have, the better, of course, in a way. We review the core project itself as well. We look at the testing specifically. Are there tests that can be run? How much of the actual project are they covering? Are tests running continuously amongst multiple contributors, or is it a manual thing? And then finally, we look at release engineering. How long does it actually take from a decision like this, how the source code looks right now, to a release, how long, how much time, and how much effort is it to get to that. And then we'll just go improve all that stuff. It's basically the same stuff. We look at the people and the processes. We establish things that they may not have established yet. We help them with their testing infrastructure. We help raise their code coverage, automate releases, all that kind of stuff. And some of these projects are very old and established, and they have all this stuff already because they've been doing this for a while. But every project has technical debt. Technical debt in this context translates to it takes a little longer to get a fix in, or to evaluate whether a fix is safe to release, it doesn't break anything else, or keeps the maintainer's attention away from actually doing anything other important. So if none of the typical things here apply, we'll go to lowering technical debt. This all starts with your typical video conference call, so everybody gets to know each other. And in that call, we're kind of trying to establish what is the difference between this hypothetical model of what any open source project could be doing to be most resilient. Like it just takes 5 minutes from report to a new release would be really nice. And what we can do then to bridge that gap. And if there's nothing there, we'll just do the lowering technical debt bit. Another important thing that we're doing here is we meet the projects where they are. Some projects are on GitHub, some are on GitLab, some are on mailing lists, some have a Zulip instance, the chat software somewhere. And we want to make sure to not take away from open source projects more than we need to, so that we're not wasting any of that time, and then make sure we contribute as much as we can. Technically, we also meet projects where they are. For example, for PHP, we did an infrastructure project for an infrastructure that has been organically grown in the last 25 years. And there was a lot of opportunity for helping change the way they run their servers and the services that make up what the PHP project needs to do. Release candidates, releases, downloads, security attestation, huge things that are incredibly important for the trust chain that depends on PHP. And we could go in and say, okay, the best practice in this area is you get a team of 6 DevOps developers, SRE type people, and you go all in on various things of automation and resilience and kind of stuff. But that's not how that project works. It's just a handful of people who are very diligent, very good at their job. They just needed a little bit more help consolidating what they have. So we didn't go in and say, okay, this is the future, you have to go there, which meant for them jumping through several hoops to get there. We just leveled them up one level from where they were to make their lives a little bit easier, instead of coming in and be all smartass about, hey, other projects do this, you should do that as well, rather than come in, okay, well, how can we make your life actually easier? Bunch of challenges. Ooh, we found those. Some projects didn't even take the initial call with us. They looked at our website and said, well, you're doing web development and offline database stuff. Surely you cannot contribute to our project in any meaningful way. It's a waste of my time. I'm not actually going to talk to you. And fair enough. If you don't have the right impression that we would, or if you have the impression that we waste your time, don't take the call. I would do the same. But the learning for us is we need to, for us and the STA, we need to better communicate the services that we can actually do, and we'll get to that later. That there's for all the projects that did take the call and were similarly skeptical in the beginning, we always found at least a little thing that we can do that made their life a little easier. But we learned from this to be more upfront about what we can actually do. Now there's a dedicated landing page on our website that explains the kind of stuff that we do, and we started publishing retrospectives from the projects that we've done so that people can see, oh, that's the kind of stuff they can do. Okay, that's fine. We have a bunch of those things as well. So that was a good learning. The next thing is each engagement for each of the projects has a time scope of about 40 to 80 person days. That's a substantial amount of time for any open source project, and we get a lot of work done in that time. But some open source projects need a lot more time, and it comes in 2 flavors. The one is the ramping up, like being able to actually learn all the things that you need to know to meaningfully contribute to the project independently, so that you're not coached by the existing contributors all the time, because that's taking away time from them. We had one project that said it takes 2 years full time to onboard here. We're like, okay, we can't do that, sorry. There's other projects, I will name it, auto tools, which is essentially unmaintained at this point, which should make you all very scared. Let's please fix this. Well, we could say, no, the ramp up to start fixing it is actually not that hard for the skills that the team already has. But if we spend even if we stretch it to 120 person days, we would get 3% into what's actually needed with these systems, with these projects to going forward. And it's not worth getting that started and then nobody takes it on. So these projects need longer sustained funding situations. And that's what the bug resilience program, or now the lowering technical debt program, just don't provide. So we need to find other models there as well. Some projects are really busy. So we've designed this process with the projects together to make sure that there's as few connection points as possible. So we don't have to, hey, do you have enough time for another call? Can you review this email? So we don't have to do a lot of this. So there's a few coordination points that we have to have, but we minimize them as much as we can. And still, some projects get through that within a couple of days, and then some projects need months to do all this. That's not a complaint. I'm an open source maintainer myself. I have done for a long time. Sometimes you just don't get to a certain thing, even though you know it's going to benefit you in the long run. It's just the reality of working in open source. And then one thing that I was sure wasn't going to be a problem, but the team really wasn't sure wasn't going to be a problem, is that if you jump into these 12 or however many they are different projects, they're all different programming languages, they all have their own choices of build system and testing environment and CI environment and how they contribute patches. There's a whole slew of new technologies that you have to learn very quickly to be able to do a useful contribution. And again, the team wasn't sure if they could do it, but after a few of those projects that went very well, they gained more confidence. And I always knew they could do it, but it's very nice to see that they now are they take the calls now and say, no, we can do this, it's fine. We've seen this kind of stuff before. It doesn't matter if it's PHP or Python. We can, whatever, we'll just do the thing that's needed. A bunch of highlights I want to mention. And I've pulled these from the team. These aren't just mine. So this is stuff that the team said, please talk about this. We're very proud of that particular work. Most of the things, all of them I'm proud of as well, but they did the work, so they get to be even more proud. So Yocto, again, is this system that allows you to build your own Linux system. And that includes your own the custom drivers you need and all the software you need to run, to do the networking and all sorts of stuff. And when you put together such systems, your users will deploy them, and they will also want to make sure, well, is this actually secure? So there is automated security scanners that say, hey, is this version of this software, say the Apache web server that you're using here for some reason, is this actually secure with the version there? And then they compare, these automated tools compare the project against a list of commonly known vulnerabilities, or called the CVE. There's a centralized list that shows here's every CVE, every vulnerability ever found in every piece of software, gets a number and says this version, this software at this version is vulnerable against this certain thing, and they fix it in this other version. That seems like a very useful thing. The problem is this list is not very well maintained. We have closed the CVE that was open in 1998. We've closed the CVE, and we found the proof that a CVE was worth closing in a PDF from 1993. We did a lot of archival work in SourceForge and Internet Archive and all sorts of things that some of the people here have never heard of because they've long come and gone, but it's all still there that you can look at and see where a particular piece of software was vulnerable. So what we did for Yocto, the fun problem is now Yocto inherits all those CVEs. Because the scope of Yocto is every FOSS project, everything, right? So what these people usually do when they say, okay, I have this piece of software here, and then they see, oh, there's Apache in there, and that's vulnerable to this thing because of the CVE from 1998. Any human looking at this says, well, that's clearly bollocks. This has surely been fixed in the 90s, and we don't have to worry about it, but nobody updated the report that these automated tools make the comparison against. So everybody has to maintain an ignore list. Say, okay, yes, this will flag, but ignore it. We have vetted it to be not applicable to our software, or in the way we're using it, or we already know this is fixed, but ignore this for now. So what we've done for Yocto is go through over 300 CVE reports and try to find, can we actually close them so you don't have to maintain the ignore, like Yocto doesn't have to maintain the ignore list anymore. And we've submitted them all to NIST, the National Institute of Standards and Technology in the United States, that maintains the central registry. And we have over 60 already applied, and then they send us an email, by the way, thanks for all this is great. By the way, we're hiring a bunch of new people so we can deal with all this. So we basically did a good spam there. And we keep getting emails like every couple of months, like, okay, now here's another batch that we got through. Thanks for those. And the nice thing now is that not only Yocto has to maintain an ignore list, Yocto just has the longest one because it inherits everything from every Linux distribution, from every open source project, from every version of every open source project, and so on. But Ubuntu, Debian, FreeBSD, Gentoo, they all have their own ignore lists. And by fixing the CVEs at the central place where they originate, we're making all of those ignore lists obsolete. So we did this for Yocto, but that helped everyone who bundles open source software. So that's very high impact work that I'm very, very happy that we could do. And directly, similarly, so this wasn't a project that, like, we didn't work on the core of Yocto because that's not, like, is now a specialty, but we did something in the periphery of the project that was nevertheless useful. Likewise, the next thing we did is Yocto has a lot of web-based tooling that allows them to manage what they do, and part of it is like performance graphs, so they can see performance regressions over time and fix them. But the usability of those graphs were rather poor because they built it themselves and they're not web developers. Now, we spent comparatively very little time to make it a little bit more user-friendly. It's the kind of work that we're really good at. And basically, right after putting this live, they said, oh my God, there's a performance regression that we missed because of the poor usability, and you fixed that for us right away, and then they could work on that. So that's like web development for a systems integration project is very far away from the core, but has nevertheless a huge impact on the project. Next one is systemd. A subcomponent of systemd called systemd resolved does DNS resolution. It turns host names into IP addresses. If you do a browser lookup, you can extrapolate from here. It's an extremely essential service of any Unix system or Linux system in this case. And we raised the test coverage from about 3% to about 65%. Ignore for a second that a systemd component has this little coverage. It's very good code in general. As we found, we did find a few edge cases and bugs that they fixed real quickly. We learned a lot about how DNS works on lots of levels. But it was a pleasure to work on, made a real difference for everybody who's running systemd, which is almost everybody, if they like it or not. And yeah, helped out make a piece of foundational software a lot more reliable by raising the test coverage. Another big thing that we did for systemd, which again has nothing to do with the core component, is that for historical reasons, systemd had 2 places of documentation. And they have both grown for a period of over 15 years. And it's very tedious and annoying to find anything out about systemd. You don't know where you need to look first. Somebody's documented there, you think that's it, but maybe it's also documented in the other side, but a lot more thoroughly, and that's what you actually need, but you never look there because you found something on the other side, but now you don't know what, it's very annoying. I don't have to explain why this is terrible. But what was terrible is that it's a lot of documentation. It's a big, systemd has long evolved, and it's a large project. So there's lots of documentation, and both of them has grown organically. So we unified this into a single documentation system by finding an information architecture that could encompass both styles of documentation into a single format. We used Pandoc for the translations of these different physical formats, but we had to write a bunch of plugins to work around the special cases that they have been using. It's a tremendous amount of work that none of the core contributors ever should attempt because that's not their core competency. They should keep writing very good C code to make systemd better, or review our patches for the test suite. But they shouldn't spend that many weeks of work on converging 2 documentation systems. So this is a perfect type of project that the STA can fund to make the whole ecosystem better. Servo, like I said, the only independently funded open source web rendering engine. They have a sub-project called Servo Shell for desktop and mobile, specifically Android, which is where you can actually use the web engine, like a little browser with a browser bar and back and forward button, like the usual stuff. But it looks like somebody just threw that together for a demo. Like, the buttons are way too small. There's no tooltips. Like the usual affordances that you have in a properly polished UI are just not there, because that was never the goal for this project. But now they are at the point where they want more people to use Servo. It is like, while Servo isn't finished, it is getting better and better every day, and they want more people to use them, but people not using it because the shell, the browser of it, isn't really usable. So we did two things for them: a design brief for here's UX changes that you should be making to make this more approachable. And then, because the desktop version is undergoing more like a technical architecture change, that will make it a lot easier to contribute to in the future. Within the time that we've had to focus on the mobile version. So we're actually implementing the things that we said you should be using. So I don't know, by the end of next week or so, there should be patches to Servo on Android that make it look like a normal browser. Still doesn't do a lot, but looks a lot more than a technical demo that people who are casually interested will turn off right away. Again, yeah, for PHP, I'll bring this back. I already mentioned we did some infrastructure work for them, but the nice thing about that is the same people that got me started in open source 25 years ago were still working on PHP, so I got to hang out with my very old friends and do some cool work. It's so nice how this all connects. Genome, again, very cool. It has a feature called Blueprint. It's a way to describe user interfaces in a kind of like easier text format, rather than writing complicated code to make it all work. But Blueprint had a lot of important things missing. We added a good bunch of them. I don't know if we got to all of them eventually, but we did a good chunk of important things there. So that it's easier to build good genome maps without doing tedious programming work. And then we also built a linter for Blueprint, an automatic checker that could look at things like, oh, this button doesn't have a title, so somebody with a screen reader doesn't know what the button does. Or up in the hierarchy, you defined a black background, and further down in the hierarchy, you're using a black text somewhere, and you're not seeing it because it's far away from each other. We can automatically check, okay, no, you can't, there's not enough contrast, black on black text, you can't read the text. And these kind of affordances allow people to build better genome maps and more accessible genome maps. So that's, again, very nice. And then again, something that has nothing to do with the core project. We've done other things with these projects as well that are more to the core of them, but the highlights that the team asked me to refer here is the revamp of the website and make the projects more approachable for new people. These are relatively small projects, so one of the things I want to do is more attractive for new contributors. So we added a contributing guide, a code of conduct, made the websites look nice, did a nice logo, updated a nice logo, so people look at these and say, oh yeah, this is a cool thing I want to contribute to, rather than, oh, this looks like somebody did it in the 90s, because they did. And then just a personal thing that came up time and time again in these initial video calls that we had with people. Like, some of them are very skeptical, where we had to talk a lot about, like, here's the kind of stuff that we can do, and then maybe they thought of something. Sometimes they came with a list of things, hey, can you work on these and these things? But there was always this, when we thought about, okay, brainstorming, what else can we do? We told them, basically, give us any technical debt you have, any of these projects that are weighing you down, that's in the back of your head, that you always wanted to do and never had any time for, that are relatively easy to delegate. And at that point, there's a glimmer in the contributors' eyes, in the maintainers' eyes. They say, you can do all that? And they were like, oh my God. And then it opened like the floodgates. Everybody who's an open source maintainer knows the feeling of all the things that you could and should be doing in your project. And then you suddenly see this lift. They sit up, they have a glimmer in their eyes. It's an indescribable feeling of personal relationship. It's really nice to be doing. Tiny humble brag, we did all but one project under or on time. If you want to learn how that works, talk to us later. I'll be rushing through the last bits so you can get to lunch. We severely reduce technical debt in all projects in some form or another. Sometimes freeing the time of a core contributor is just as important as doing a direct contribution to the core of the project as well, so they can focus on the stuff that they're actually good at. And making projects more approachable has like compounding effects for future contributors joining the project. In conclusion, we're honored to have done this work. It's extremely good to have been part of the resilience process here in Germany and the EU and strengthening open source projects worldwide. By the way, these are all kind of sort of quotes from the team. We'd love to continue this work and see it expanded. We already know the Sovereign Tech Agency has been funded for another 4 years with a slightly expanded budget, but also we need more people doing this. We need more agencies doing it. We need more, globally, more governments need to put money that way. We need more budgets available. There's a talk tomorrow afternoon that you shouldn't miss by Felix Reda about an initiative to get an STA equivalent for the EU going. Please go and watch that. And like you see, we could only do is like, I'm very proud we did these projects, and it's not just a few projects, it's a sizable number of projects, but also it's just a bunch of projects. We're a small team, the STA has a small budget. Like, there's a lot more open source that needs our help. So I really hope this becomes a model that we can develop forward. And yeah, if you have any questions about any of these things, come talk to me. Thank you.
All right, thank you, Jan. We'll start off with a question from online. Is there any program to pursue entrepreneurial mentorship for FOSS, like Tech Women Mentorship? I guess it's more a question for...
I didn't get 3 of the last words.
Is there any program to pursue entrepreneurial mentorship for FOSS, just like Tech Women's Mentorship?
Oh, probably, but that's outside the scope of this talk, so finding technical mentorship. I'm sure there's programs like this, but
we'll ask from the SDA folks. Any other questions in the room?
Thank you for the talk. So if a project wanted to get stuff fixed, how could they get in touch with you?
Right. The projects apply with the STA and say, hey, we're a project, you have to write up, like it's a single form that takes you about 15 minutes to fill out. Say, this is the project we are, here's why we think you're important. This is why we think you should fund us, why we're important. And then the STA will take some time to evaluate. If you're an obvious candidate like PHP or Python, basically you just like get passed through. If you're a smaller project, there's a little more thorough investigation there. But like, for example, Poplar is basically one guy in Spain that has a bunch of friends that help occasionally. It's a lovely project to work with. And again, if you do anything with PDF and open source, or including all the OpenDesk kind of software, is using that technology. So even if you have a tiny project that you know has a lot of downstream users, you can make your case relatively easily. And then the STA. If you have your own money, that happened as well. If a project has its own money through some other way, but they don't have any people to do the work, come to us as well. We can help you with that as well.
Then thank you, Jan.
Thank you.